Good morning, everyone. Myself, Jyoti Prasad, belongs to RMD Engineering College, EC department. Today, I am going to discuss about duobinary encoder, how we are going to check with respect to particular data, a problem. The previous video we have discussed about duobinary coding, nothing but correlative coding. So where we have seen these two equations. This is the equation where we implemented the transmitter bk plus bk minus 1. So like I shown here, so bk is this path, the upper path, a line, and this one is a delayed sequence. If we add both together here, the sequence is after passing through the channel, the sequence is said to be ck. The received sequence is ck. So that one we are taking as an output sequence. So after receiver, at the receiver, we will do the same logic. We will subtract or we will subtract this time delay. So that is called as ck minus bk minus 1 cap. After performing this operation, then what is the binary detected sequence? Is it equal to transmitted sequence or not? We are going to check in this problem. Consider a data. You can assume your own data also. Here I have taken 00110100. Have taken 8-bit sequence. 8-bit sequence. Applied to a duobinary encoder. So find the receiver output. Here I have not specified, I means in the data problem, they have not specified about precoder. So we have two circuits, duobinary without precoder is the first circuit, duobinary with precoder is the second circuit. So I have taken the first one. This is the example for first one where the input sequence. So I am taking with 0, k equal to 0 starts with k equal to 0 to ends with k equal to 7. So it totally put together 8 bits. The same data, whatever they have given, I have written over here. So in the same order, 0 0 11 0 1 00. So like we have discussed in the theory, 0 will be represented as minus 1. 0 will be represented as minus 1, and a binary 1 will be represented as plus 1. Plus 1. So I have did the same thing here in this step. 0 is represented by minus 1 and 1 is represented by plus 1. Here on all the steps up to the last. Now, so we had the bk. So here we know the bk value here. We don't know the value of bk minus 1 for the present instant. So for each instant we should indicate bk minus 1. So consider from the first one. First one, no sequence is there. Nothing is there in the starting initial stage. We don't have anything in the bk minus 1. Say it is the nothing. So empty. So in the next instant k equal to 1, the previous one will comes as a bk minus 1. So the previous instant is k equal to 0. That will come here as a minus 1. So similarly, k equal to 1 is the previous instant for k equal to 2. So bk minus 1 value at k equal to 2 is previous one, minus 1. So similarly, for k equal to 3, what is the bk minus 1? K2. So the value is plus 1, we have replaced this one. So each time the previous one will come as an output. I mean the content. Previous instant data will comes as a bk minus 1, like here we donated. So now what is the operation performed between bk and bk minus 1? The addition of these two things is nothing but ck. So here we will have one doubt: what addition, modulo 2 addition or normal addition? Here the binary sequences have been converted into voltage levels. So normal summation, normal addition operation. So minus 1 and minus 1, which will give minus 2 here, and plus 1 minus 1 will gives 0 here, and here plus 1 gives the plus 2. So similarly, I will perform this operation where the binary sequence is converted into voltage levels. I said previous video I told that the binary 1 and binary zeros will be converted into three levels: minus 2, 0, plus 1. So three voltage levels only there. Other than that, nothing we are finding here. So this is the transmitted sequence. So how we will receive the sequence? We do compensation. What compensation? We added bk minus 1 there at the transmitter. So I am subtracting here a compensation for what I did in the transmitter. So from the received sequence, I am subtracting, or from the CK transmitted sequence, I am subtracting the BK minus 1, the delayed sequence. So here, what is the CK minus 1? Nothing is there. So that's why for the first instant, BK as it is, I am writing here. BK, whatever BK value is there, as it is, I am writing here. This is the default value, minus 1 I have written here. Now, what is the CK value? Minus 2. Minus 2 minus 1. Minus of minus means between these two things. I am performing the operation between these two things. Minus 2 minus of minus 1, that means minus 2 plus 1, minus 1. So now perform operation between these two things. CK minus BK, 0 minus of minus 1 plus 1 will come here. The operation between these two things, 2 minus 1 plus 1 here. Here 0 minus 1, minus 1 will come here. And here 1 minus of minus, sorry, 0 minus of minus 1 plus 1 will come here. And here 0 minus 1, the result is minus 1. And here minus 2 minus of minus 1, the thing means minus 2 plus 1 is minus 1. So now what is the detection rule in the duobinary coder? So the detected sequence, the detector value, if the value, what is the value is equal to 1, minus 1, if the value is minus 1, negative, assign as binary 0. If the received value is voltage is positive, plus 1, binary 1. So for the negative values I have taken 0, 0, 0, 0, 0 here. For the positive values I have taken, one, 1, 1 here. Check the top row and the bottom row whether the transmitted sequence is matched with the received sequence. See the input, double zero, double one, zero, 1, 0, 0. So double zero, 1, 1, double one, 0, 1, double 0. So the transmitted sequence has been received. So in this way, we are going to encode the sequence into voltage levels and transmit, where we are calling adding some ISI, correlative coding. At the receiver, we will compensate. So we have transmitted without any errors. So this is called as correlative coding. If we go for duobinary coder with precoder. So this is first dotted line section is called precoder. The second one is called as uh, modified duobinary conversion filter. Thank you.